let's find out coordinates of some of the given points. Now, we have seen earlier that René Descartes was a great French mathematician who actually solved how to define the location of any point given in the plane. And because of this, we call René Descartes the father of coordinate geometry. Coordinate geometry is the branch of mathematics that deal with locating a specific point on a given plane, and more broadly is locating a straight line or any curve or any graph for that matter on a plane. And René Descartes, because he was the first person who gave us, the whole world, how to locate any point on a plane, so we refer to coordinate plane also as Cartesian plane in honor of René Descartes, and we refer René Descartes as father of coordinate geometry. So we know that what René Descartes suggested was, he said if there is a point, let's say we have a point P over here, how do we find out the location of this point? So we have two number lines. These number lines are at 90 degrees to one another. So we call the x dash number line as x-axis and the y dash number line as y-axis. So we know that. So what René Descartes he suggested was that, well, first we have to find out the perpendicular distance of the point from both of these axes, the x-axis and the y-axis. So how do we do that? Quite simply, we draw perpendiculars from the point on both of these number lines. So we will draw something like this, and let's say this point, let's say, so the point where we get the perpendicular coming from P on the y-axis, let's say this point is A, and similarly the point where we draw perpendicular on the x-axis, which is this point, let's call this point as B. So what we have is, we have these two angles 90 degrees, and this is the origin. Origin is where both the number lines or the axes they meet, and we refer to that as uppercase letter O. So after we have dropped the perpendicular distances, what René he suggested was that, he said the perpendicular distance from y-axis. So this is the point, this is y-axis. So what is the perpendicular distance? Perpendicular distance from y-axis is the length AP, right? This is how far away the point is from the y-axis, right? So the length AP is measured along x-axis, because AP is nothing but OB, right? AP is nothing but OB, and we call that x coordinate, x coordinate. So we say this length AP is the x coordinate of the point P. So similarly, if we look at the distance BP, this distance, right? This is how far the point P is away from x-axis, but this length is the same as OA. So BP is the same as OA, and the distance from x-axis is measured along y-axis, and so we call that y coordinate. So this is equal to y coordinate. So this length is equal to this length, and this length is equal to this length, right? And then René said that then we can say the coordinate of this point P, we can put that in the parenthesis, and we write the x coordinate first, then comma, then the y coordinate, right? Now we have seen that also when we have a plane and we put our x and y axis, it divides the plane into 4 equal parts. So we start from the x-axis and we go counterclockwise direction. The first 1/4 part, we call it quadrant 1. The meaning of the word quadrant is basically 1/4, right, or 1/4. So quarter is 1/4. So quadrant is the first 1/4. And we always start from the x-axis, the positive x-axis, right? This x dash, this is the positive x-axis. And y dash, I should say, if this is origin, this point, so OX is the positive x-axis. So we start from there, we go counterclockwise, anti-clockwise direction. So the first 1/4 is quadrant 1. The second 1/4 is quadrant 2. Similarly, as you can guess, the third 1/4 is quadrant 3. And the last 1/4 is quadrant 4. So our axes, x-axis and y-axis, it divides the plane into 4 equal parts, and each one is called as a quadrant. Also, the entire plane on which we have our x and y axes, we call them coordinate plane. Also, we refer to them as Cartesian plane, as we talked earlier in honor of René Descartes, or simply these are x and y axes, we refer to them as xy plane. So they all mean the same thing, right? And also, so now let's take a look at, generally speaking, if we have any given point, how can we find out the coordinate, right? So if we have any given point, all we have to do is we simply have to find out the perpendicular distance of this point from both of these axes. So this is our y-axis and this is our x-axis, right? So all we have to do is we have to draw perpendicular from here over here, and wherever this point is, we have to measure this length. So we have to find out what is AP, because AP is x coordinate. So in short, I'm writing it x here. And then we drop a perpendicular, so this is 90 degrees. And then we drop a perpendicular on the x-axis. And this, let's call this point as B. So BP will be the y coordinate, right? So we just find out these values, whatever these values are. And then we say the coordinate of our point P is x comma y. So this is how we find out the coordinate of any point. Now let's take a look at some examples and see if we can actually figure this out by ourselves. So these are some random points that we have. So how are we going to find out the coordinate of the first point? So what we are going to do is that we are going to simply draw perpendicular on both the axes, right? So let's write our axes over here. So x, x dash, y, y dash. These are our axes, x-axis, y-axis. And this is the origin. So for the first point, we draw perpendicular like this. So if this is our point A, so what we do, we draw perpendicular on the y-axis and x-axis, right? So remember, the distance away from the y-axis, that is our x-coordinate. So the x-coordinate in this case will be this distance, which is measured along the x-axis, right? So in your mind, you can actually relate it with, we write any point x comma y. So how much along x-axis, we can think of it this way, and then how much along y-axis. So we can try to remember it this way. X for how much along x-axis, y how much along y-axis. So A, x coordinate will be how much along x-axis, which is this length. So it looks like it is about 4. So we say this is 4. And then y coordinate is going to be this length. How much along y-axis? Looks like it is about 6. So we say coordinate of our point A is 4, 6, both within bracket. Let's find out for the second point. So if this is our second point, so what about the coordinates of this point? So we drop the two perpendiculars. So what will be this value here? So this value will be how much along x-axis. So this point along x-axis looks like 6. So we write 6 over here, comma, how much along y-axis? 3. So we say point B within bracket 6, 3. So 6 units along x-axis, 3 units along y-axis. Let's take a look at our next point. So our next point is here. Let's call this point C. So again, this is on second quadrant. So these 2 points are on first quadrant. This point looks like to be it's in our second quadrant. But we do the same thing. We draw perpendicular on both the axes. So first, to find out x, how much along x-axis? So which is this distance. So looks like this will be -7. Remember, on this side, which is OX dash, this is negative direction of x. So this will be -7. So we write -7 over here. And then next is how much along y-axis, which is over here, that will be +4. Right? So this will be +4. Now let's find out these 2 points are remaining. So let's say for the next point, it's the same step. For this point, let's call it D. So we drop the 2 perpendiculars. Now the first one is how far along x-axis. So how far is this along x-axis? -4. This point is -4, right? So this is minus 4, comma, how much along y-axis? This is minus 3. So remember, so if this is our origin, uppercase letter O, so OX is positive direction of X, OY is positive direction of Y, OX dash is negative direction of X, and OY dash is negative direction of Y. So this length, how much along y-axis, is minus 3. So our point D, which is in our third quadrant, this is quadrant 1, this is quadrant 2, this is quadrant 3, and this is quadrant 4. So our third point is D, which is minus 4, minus 3. And finally, if this is our last and final point, how do we find out E? We will do the same thing. We'll draw perpendicular on both X and Y axis. So how much along X axis? It is 5 units along X axis. Remember, this is the distance. So we write 5 over here. And then how much along Y axis? Looks like minus 5. So this is minus 5. So this is how we find out the coordinates of any given point on the coordinate plane or Cartesian plane or the XY plane.